20 years ago, the movie I, Robot imagined a world where humanoid machines cooked our meals, cleaned our homes, and quietly learned to think on their own. At the time, it felt distant, a warning wrapped in science fiction, but today that warning looks more like a blueprint. Tesla's new Optimus Gen 3 can walk, lift, and learn from human behavior, gaining new skills without rewriting a single line of code. Elon Musk believes that robots like this could eventually outnumber people, forming a mechanical workforce measured not in thousands but in millions. The only question is whether we're building humanity's greatest invention or its most unpredictable experiment. Musk's vision has always stretched beyond cars. While other automakers focus on engines and batteries, Tesla positions itself as a robotics and data company, one that just happens to make vehicles. Optimus is the next logical step in that evolution. The plan is straightforward but monumental. Use the same production systems that made electric cars mainstream to mass-produce humanoid robots. To most, that idea still sounds impossible. But then again, so did reusable rockets and consumer electric vehicles a decade ago. Tesla's factories are designed for robots already. Every conveyor, every assembly process, every line worker surrounded by robotic arms. It's all a controlled environment, perfect for early adoption. In many ways, Optimus is being built for Tesla before it's built for the world. When the first Optimus prototype took the stage in 2022, it could barely shuffle its feet. Fast forward just 3 years, and the Gen 3 version can perform thousands of movements with speed and precision that once seemed out of reach. Its balance is fluid, its hands are dexterous, and its frame is light enough to operate for nearly a full day on a 2-hour charge. Tesla calls it the first production intent humanoid, meaning every bolt, motor, and chip is designed with manufacturing in mind. Not a one-off experiment, but a blueprint for a future product line. Behind the sleek exterior, the robot's brain runs on modified self-driving hardware, the same platform that powers millions of Teslas already on the road. That gives it a distinct advantage, a mountain of real-world perception data. Every mile driven, every obstacle avoided, every frame labeled by Tesla's neural networks feeds into a system that now helps Optimus understand the physical world. The overlap between cars and robots is deliberate. Musk once said, "A car is a robot on wheels. Optimus is just a robot on legs." If that's true, Tesla already has years of robotic experience that few competitors can match. But there's another layer: training. Tesla's AI engineers are using simulation software to create digital twins of real environments, allowing Optimus to practice tasks thousands of times before ever touching a real object. It's a form of accelerated learning, virtual trial and error, compressed into hours instead of weeks. Tesla's internal testing confirms that several Optimus units already operate at the Fremont and Texas gigafactories, handling repetitive tasks such as component delivery, inspection, and data logging. These are mundane duties, but that's exactly the point. Automation always begins with the boring work that humans would rather not do. Each deployment teaches the next batch of robots. When an Optimus adjusts its grip, identifies an obstacle, or corrects its gait, that data syncs to Tesla's training servers. In essence, every robot Tesla builds becomes part of a shared, evolving intelligence. It's not just one robot learning, it's a collective brain that improves with every unit added to the network. And that's what separates Tesla from the smaller robotic startups still teaching their machines task by task. Recent public appearances have also served as field tests. In Los Angeles, Optimus greeted diners at Tesla's retro futuristic restaurant and served snacks to customers. In Times Square, a similar unit handed out Halloween candy to passers-by. To spectators, these moments looked like PR stunts. To engineers, they were practical stress tests, Unpredictable lighting, crowds, noise, and human behavior, the kind of chaos you can't simulate in a lab. Even simple gestures like handing a child a piece of candy require complex coordination, depth perception, grip adjustment, balance, and social timing. The fact that Tesla is confident enough to deploy Optimus in such environments says something about how far the technology has come. The hardest problem remains the hand. It's what separates a general-purpose robot from an industrial arm. Optimus's new design places tiny actuators, sensors, and controllers directly inside the forearm, giving each finger independent movement. That lets the robot pick up fragile glassware, tighten screws, and even manipulate fabrics, a field robotics researchers have struggled with for decades. Musk calls it a biological problem wrapped in an electromechanical shell. To match the precision of the human hand, each Optimus must coordinate dozens of micro movements within milliseconds. It's one of the most difficult mechanical challenges ever attempted, harder, in Musk's words, than building a car, a rocket, or even a gigafactory. And the goal isn't just motion, it's instinct. When a human drops a tool, we react in fractions of a second without thinking. For Optimus to reach that same level of reflex, Tesla's AI models must predict motion before it happens. That's the true frontier. Artificial intuition. Tesla isn't the only player. Figure A, Eyes Humanoids, are now performing live trials on a BMW production line, reportedly working up to 10 hours per shift. Boston Dynamics continues to refine mobility and balance, and China's Unitary Robotics is racing to produce low-cost models for research and industry. In Japan, companies like Toyota and Honda are re-entering the humanoid race after years of dormancy, seeing renewed demand in aging societies that need labor assistance. The difference lies in Tesla's data ecosystem. No other company has access to such an enormous, continuously updated map of the world. If Optimus can tap into that system, learning from the same sensors that feed Tesla's self-driving network, the rate of improvement could be exponential. In effect, the world becomes Optimus's classroom, but progress brings new tension. If even a small fraction of Musk's projections come true, the global labor landscape could shift dramatically. Tens of millions of robots, priced around $40,000 each, would create a market worth trillions, rivaling the entire automotive industry. Supporters call it liberation from repetitive work. Critics call it the beginning of an unemployment wave we're not ready for. Economists warn of what they call the missing middle, where high-skilled jobs and low-skilled jobs remain, but the stable middle tier vanishes. The last time that happened was during the Industrial Revolution. Entire professions disappeared in a decade. The difference now is speed. What once took generations may happen in just a few years. Already, some manufacturers are exploring co-working setups where robots handle heavy lifting, while humans oversee quality and creative decisions. Others imagine entire factories, staffed mostly by machines, with only a handful of engineers supervising hundreds of bots. Whether this shift leads to widespread prosperity or deeper inequality will depend on how quickly education, policy, and culture can adapt. Safety is another frontier. Humanoid robots aren't confined to cages like traditional assembly arms. They move in human spaces. That means new standards, automatic stop zones, encrypted communication channels, and constant sensor monitoring to prevent collisions. Most likely, robots will operate under strict supervision for years before earning true autonomy. Musk insists Optimus will include built-in safety limits, capped speed, capped torque, and manual override controls. In short, it should be physically impossible for a single unit to harm a human being. Still, the parallel to iRobot lingers in the public imagination. It's not rebellion people fear, it's dependency. What happens when we rely on a machine for every basic task? 3 signals will show when that future truly arrives. First, consistent demonstrations of real dexterity, uncut footage of robots performing multi-step tasks with everyday objects. Second, independent pilots proving that humanoids can complete full work shifts safely and efficiently. And third, manufacturing evidence, supply contracts, tooling and software updates that confirm Tesla has moved from prototypes to genuine mass production. When those pieces fall into place, Optimus won't be a concept anymore. It'll be infrastructure, as ordinary as an elevator, as expected as a smartphone. From a shaky prototype in 2022 to a robot that can cook, serve and self-learn, the progress is undeniable. Whether this becomes the world's most useful tool or its most disruptive invention will depend on how we choose to use it. Either way, the future isn't approaching, it's already here. And if Elon Musk is right, it's walking toward us on 2 robotic legs.